were at this part last week. And we were solving this equation. I don't know if you guys vaguely remember that. Kinda? Hey. I was impressed. This is the last half of 14.4. No, you did a little move on one of those things that I never even thought of. It worked perfect. I'm like, oh, that's slick. So I thought it was really cool.
Extra credit.
Oh, no. Anyway, so solving for x, we're solving for the interval between 0 and 2 pi. Sometimes you'll see it written as the interval of 0 to 2 pi, or sometimes you'll see it like this. Hard bracket 0, soft bracket 2 pi. Means the same thing. You're looking at an interval. That's interval notation as opposed to a less than or equal to. The further you guys go in math, the more you'll start to see the interval notation of it. So if I want to figure out 4 tangent squared x minus 1 equals 0, well, how many steps do we, well, what do you do first, I should say? Add 1, then what? Good. So I know that tangent squared of x equals 1/4. Now what? Square root. Good. Now, whenever you take a square root over an equal sign, what do you have to remember? Plus minus. Plus or minus 1/2. Everybody okay with that? Now, what do? Inverse it. So, what angle has a tangent value of plus or minus 1/2? Well, what triangle is the 1/2? 30, 60, 90. But wait, do any of those give me the 1/2?
No.
No. So what do you have to do?
Don't know.
That's basically it.
Huh? That's your answer?
At this point, obviously, if it's a 30, 60, 90, or even if I'm at 45, 45, 90, do any of my special triangles give me a tangent value of 1/2? No. So if that's the case, we don't know anything else. We don't know how to solve anything else. So that means we have to utilize our calculator. Okay? So like we've done in the past, there will be calculator, non-calculator part. Obviously, if this is sorted in a calculator part, you have to know that. But here's the kicker. What should I be in order to solve this problem? Radian. And this is where I want to spend a little time to show you guys what happens when you're dealing with radian value. Radians is just degrees in terms of pi. Are we okay with that? So if I start at 0, this is pi, and I go back to 2 pi. We know this is pi over 2, and 3 pi over 2. We know that all of these have some sort of value to them. Are we okay with that?
Mm-hmm.
What is pi as a decimal? Hey, by the way, Monday's Pi Day. So,
I hope that won't happen.
It's wrapped in pie.
Dude, I don't have it.
It's like
last year was much better. It was March 14th, 15th.
Oh, yeah, that's why. That's why I thought I only happened once. This is an annual thing?
Well, yeah, March 14th does come around every year.
Well, yeah, but I didn't know to celebrate it. Didn't know the day.
Does your birthday come around every year? Do we celebrate your birthday every year? All right. What if your birthday was on February 29th?
That would suck.
It would. You'd have to wait a long time to get your driver's license.
Yeah.
I know somebody who's working on
Seb was almost the 29th.
Really?
Yeah. Anyway, so if 180 degrees is at 3.14, what's at 90? Half of it.
1 point.
So what's half Well, what's happening?
1.07.
1.7.
1 point, let's see,
0.7.
no,
That wasn't cheap.
okay. And then obviously at 3 pi over 2, basically I'm adding 1.57 to this. So it'd be at 174. Yeah. 4.7, oh, it's backwards? Okay. I was right when I started
I was
writing
gonna
down.
say, I was-
And then at 2 pi, you just double 3.14, and you're at 6.28. Everybody okay with that? So now when you get your calculator value, you start thinking about, okay, this is in terms of radians. So if I have in radian mode on your calculator, if you inverse tangent of positive 1/2, what does it give you?
0.46.
What is it? 0.46. So that's telling you somewhere in here, you have an angle of 0.46. Are you all right with that? Where else is tangent positive?
4. Third part.
How would I get from this point to this point? Add pi, very good. So that decimal value, add 3.14 to it. So you know you have angles that at 0.46. And what was the other one? 3.6. Those would be my two positive angles. Are we okay with that? Now, if I do inverse tangent of negative 1/2. Remember what your calculator is doing. Where's my button? No. Remember, it's taking the angle and it's finding the tangent value dropping downward. Remember that? When you use the calculator, it's searching for angles between pi over 2 to negative pi over 2. So this is giving you a reference angle of negative 0.46 downward. Are we okay with that? But if I'm looking at it in terms of a positive revolution, what would I do to figure out if this is negative 0.46? Well, wouldn't that be the terminal side coming around here? So would I just take 2 pi and subtract 0.46? Getting decimal wise? Everybody okay with that? It looks like we have not yet done anything with decimals, so this is why it might be a little bit weird.
Could you just say it then?
That.
You know what?
This is 2 pi full round, right? I'm down 0.46. So if I take 2 pi subtract 0.46, I should wind up here. So that would be 5.78. 5.78? What was it? 78? 82? 5.82, thank you. So if I do that,
Oh, so you get the positive.
because I'm looking between 0 and 2 pi, so that gives me this value. And then isn't tangent also negative right here? So how do I get from here to here? Not add pi, subtract pi again. So if I subtract 3.14, I'm going to get 3, was it? Thank you. So these would be my 4 angle values that work between 0 and 2 pi when I don't have a special triangle. It's a little bit different
So now we're looking for decimals.
if you need to.
Okay.
If you need to, because sometimes you will. Sometimes you will have to. And it just depends on what you wind up with as far as an answer is concerned, okay? Sometimes it'll be easier. Yeah, what do you got?
So you don't want to use negative degrees?
No, because it's asking you for an answer between 0 and 2 pi. So you want all positive angles.
All right.
Okay. And yeah, the tangent, or even if it was a sine value, it would have found that negative angle here, so you would have done a reference and bounced it more. So we have, I don't think we've ever bounced a decimal value before, but it's not that bad, is it?
No.
All right, well, let's do another one. Let's change this up. Let's find this in terms of what we call a general solution. This is going to be new. This is a new way of doing this. We're going to find what's called a general solution. So I have 3 secant squared x minus 4 equals 0. What do you do first?
Add 4.
Add 4. Divide by 3. Square root it. Okay. I'm going to leave it like that for a second because secant is the inverse of what? Cosine. So if I inverse secant, what do I have to inverse on the other side? The fraction. So you just flip them.
Oh, okay.
You okay with that?
Wait, why can't you
Because of reciprocal properties. If you inverse one side, you inverse the other, keep everything
do
straight.
that?
You're inversing the trig function.
Alright.
Okay.
So that stays the same no matter what. Alright.
Yep, yep. Okay. So what angle has a cosine of plus or minus root of 3 over 2? Which triangle is that? 30/60, very good. So which angle is it?
30.
30. Now we're going to do all of this in terms of radians, okay? So if I'm at 30 degrees, my radian value is pi over 6, very good. So we're looking for plus or minus pi over 6 so I have to list these things through into, is everybody okay by knowing that you're going to be in all 4 quadrants for this problem? Because with plus and minus, you're going to get 2 in each. So if I'm at pi over 6, what's in the second quadrant with reference angle pi over 6? 5 pi over 6. Over here would be 7 pi over 6. And then over here would be 11 pi over 6. Yes, ma'am? Whatever the sign is, positives or negatives. It would just be whatever the sign value of the positive or negative it's looking for. Okay. So in this case, take a look at what happens. What's the relationship between those 2 points? What's that? Pi. Very good. To get from one to the other is just pi away, correct? And to get from this one to this one is also just pi away. So when we start talking about a general relationship, a general solution, excuse me, is how long does it take you to get to the next point? Is that next point always a specific distance from the other ones? Can you write it more simply? What we're looking at is taking something that looked like this, because if I started at pi over 6, how long does it take me to get back to pi over 6? 2 pi. Every time I'm putting this n value in, it stands for a number of times around. Every time I go around 2 pi, I'm going to wind up back where I started. Same thing with each one of these. But when you start talking about what's called general solution, That just means, is there an easier way to write this? Well, by doing it in terms of, well, are they or 2 points within this grid equidistant from one another? I can alleviate, instead of writing out 4 answers, I can just write down 2. For example, if I write down pi over 6 plus pi n, doesn't that take care of both of those? Number to get from this point back takes 2 pi. And every time I go 2 pi, I'm back at that same point. And it works for all of those.
Okay.
What I'm trying to do is write it out more simply, if I can. Sometimes you can, sometimes you can't. But by writing it, since those guys are equidistant, to get from pi over 6 to 7 pi over 6, and from 7 pi over 6 back to pi over 6, it's always pi. It's 180 degrees to get back and forth. So this is more general than this. Same thing here. Starting at 5 pi over 6 plus a pi n gets this more simply written. One of the things that I would suggest is we write these things out in terms of what are called general solutions, is you still list out what you have. Sometimes you're gonna, if you get 4 angles, sometimes you will get them where they're gonna be 2 of them are gonna be equidistant from one another. Sometimes you won't. Sometimes if it's just a positive value, you might be able to write out just 2 of them, and you'd have to write out plus 2 pi n twice. If you get the 45s, if you have all 4 45-degree angles, you'd write it out in terms of, well, 45 to this one is 90 degrees away. 90 degrees would be pi over 2. Okay? There's little subtleties within the problems as you go through. But my answer for this case, yes, ma'am.
So for the 45 one, we could write down all 4 angles plus 5.
You just have to write down one of them. If it's plus minus pi over 4. You'll see it when it comes up. Okay? I don't want to get too, I want you guys to think about all of it right off the bat. God bless you. Let's try another one. General solution. No, you cannot divide by tangent squared, because you eliminate solutions. When you're solving these types of equations, you have to set one side equal to 0. So what are you going to do? Subtract the tangent squared. Is it okay if I put 0 on the right and just rewrite it? So I have cosine x tangent squared x minus the tangent squared equals 0. Yes, ma'am.
Do we have to add?
When you're solving equations, it's helpful to know that you're solving for an equation. It's not like the simplify stuff. I'm not going to yell at you if you don't. I try to make sure I write it when I do equations because I know that's what I have to. I'm solving for it, but it's not good. So now you start thinking about how do you solve for x? Well, you've got 2 different trig functions, but you have 2 terms, don't you? What do they have in common? Tangent squared. Factor it out. Oops. Just like you would factor out a polynomial. The polynomial in this case happens to have the nasty 3-letter words of tangent and cosine. Actually 4 letters if you want to throw tangent of x and cosine x.
If you factor out the x, would you still have the...
It's still there, yeah. Okay. Do you have 2 terms now that are set equal to 0? Yeah. So you set them both equal to 0. And you solve for x independently of one another. Okay. So in this case here, what angle has a tangent value of 0? What angle has a cosine value of 1? Well, in When you see ones and zeros, what should you be thinking about? The quadrantals, yeah, those things. Think about the quadrantals. 1, 0, 0, 1, negative 1, 0, 0, negative 1. Which one of those gives you a cosine value of 1? Cosine is that. Cosine is x. So which one is it? Remember, we start with a general solution. You're right. It would be 2 pi, but wouldn't it be 0?
Oh.
So this one would be x equals 0. Okay. Nothing else there gives me a 1. But where is tangent equal to 0? Remember, tangent's what divided by what?
Sine over cosine, so y over x.
So it's got to be y over x. Which one of those is y over x going to be equal to 0? 0 and? Y over x. Y x. 0 divided by negative 1 is what?
Pi.
Well, 0.
Okay, well, I'm going with my answer. Pi.
Okay. So in this case here, I have 2 possible solutions. I have a solution at 0. I have a solution at pi. Are those values equidistant to one another? Yeah, how far apart are they? So my answer here, even though I'm solving, I have 2 different trig functions, it works out that if I start at 0, I get, this whole thing winds up equaling 0. If I get to here, this whole thing equals 0. If I get back to here, it's
0.
0. 1. Negative 1.
not 0.
Not, I don't know what it is, it's not 0.
So my answer then, for this case, in terms of a general solution, would be 0 plus pi n. Right. A general solution. Writing it out in terms of the most basic possible way. Not so scary, I hope.
Yeah.
Ah! That was supposed to be scary. Yeah. Excuse me. All right. What are you going to do first? Correct. Set aside equal to 0, which means I'm going to move the 4 cosine x over. I get sine squared cosine of x minus 4 cosine of x. And doesn't this look just like the problem we did a little while ago with the tangent? Or actually, it was just the last week. Very good. Take out the cosine. So you have the cosine of x times the quantity sine squared minus 4 is 0.
So you don't keep the x in there, sir?
Sorry. Now what? Set both equal to 0, right? Now, you can do one of 2 things here. Well, yeah, you can set equal to 0 just as fast. Cosine of x equals 0. and sine squared of x minus 4 is 0. Think of it in terms of general solutions. Lines up with that 0 again for cosine value. Where is cosine equal to 0?
0 at 1/2 pi.
At half pi, okay, and where else? 3/2 pi. Good. So I know cosine is equal to 0 at pi over 2 and 3 pi over 2. Now, if I want to write that in terms of a general solution, are those two values equidistant to one another?
Yes.
Yeah. So I would start with this one and write it out as pi over 2 plus pi n. On the other side, I move the 4 and take the square root. So what angle has a sine value plus or minus 2? Yes, sir.
Question. What was the last problem with cosine? Oh, wait, okay, never mind.
I think it was
Never
1,
mind,
wasn't
yeah,
it?
it was 1.
Yeah. Can I get a sine value greater than 1?
Uh-oh.
No. So am I going to have an answer for this part?
No.
Here's my answer. It's an extraneous solution. Doesn't work.
Could
Can't have a, you can have a sine. You can't have a sine value that's greater than 1.
Do you always use the one with just pi in the numerator, or can you use the 3 pi over 2 one?
Usually you start with the first one you come across as you're going through one revolution. That's kind of like the standard way of doing it. It's not technically wrong coded, but normally because you get to pi over 2 before you get to 3 pi over 2.
Yeah.
That's why they do it that way.
Sure.
I get it.
So, since taking a sine value and keeping the cosine value,
Correct.
so is since those solutions are like
Half tangent does right. Tangent doesn't have a value that you have to worry about except for if you're dividing by pi over 2. Because that's the only time you have to worry about tangent not working is if it's on the vertical quadrangle. Because you get y over 0.
yeah.
That's the only time you have to worry about it. Everything else works. And when we go to graph these things next week, you'll see it again. It's tangent's very, very easy to work with. It's very easy. She doesn't believe me.
Well, I don't know.
This one,
I
glad I could help. Good conversation.
Why don't we just do this right after the stuff we done before instead of the last 14 like we did?
Because we're gonna from time to time you're gonna see something like this. You're gonna rewrite it in terms of cosine and some of the cosecant minus 1 and things like, or cosecant, yeah, minus 1. You might see some of those. You can rewrite them through. Where's the other one I wanted to look at? It's interesting that you say, why didn't we learn this prior to 14.3? Well, this is a prime example of needing to know how to use 14.3 to solve for x. There's nothing I can do in this case because I wind up with nothing, really. But what I could do is square both sides.
Oh.
Okay. Now, if I square both sides, whoa, careful, don't kill the puppy.
I know.
Boil it out. You get 1 minus 2 cosine x plus cosine squared equals See how that side doesn't have a plus sign or anything in it? Why don't you just square it? I get 3 sine squared x. Things that make you go. That's a song from back in the day. CNC Music Factory, just in case you're wondering. Now I have cosine, a cosine squared, and a sine squared. Which trig function would allow me to write them all in terms of one of them? Would it be easier to write everything in terms of sines or cosines here? Cosines. Because the Pythagorean identity says sine squared plus cosine squared is. So here I can replace the sine squared with 1 minus cosine squared. You okay with that? That's why we learn about the Pythagorean identities, so that you can use them to solve more complicated equations. And now you have the other stuff on the other side. 1 minus 2 cosine x. Okay. So we're going to distribute and then set one side equal to 0 just like we did before. 1 minus 2 cosine x plus cosine squared equals 3 minus 3 cosine squared x. So which way am I going to move things? From left to right or right to left?
Right to left.
Good. Move everything over to the left-hand side. So if I do that, I'm going to rewrite it in descending order. Okay? I'm going to get 3 plus 1 is 4 cosine squared x. This negative 2 doesn't change at all. And then I have 1 minus 3, which is subtle trick that you can do at this point. I don't know if have we done U substitution? Okay. There's a great thing in math called U substitution. Where you take a complex looking thing and you give it one variable. It just makes it easier to look at. Okay? It makes it easier to look at so you don't get overwhelmed with what you're actually about to do. So if I use this little trick called U substitution, I get the following equation. 4u squared minus 2u minus 2 is 0. Doesn't that look a lot prettier? What's the first rule of factoring? What is it? 2. Since I'm setting equal to 0, does that 2 that I just factored out have any relevance to the problem whatsoever? No. Nope. Because I can divide it out and it's gone. So now I factor it. What times what is negative 2? You add together to get negative 1. Negative 2 and 1. So I get 2u squared minus 2u plus u minus 1. You okay with that? We're going to factor by grouping. And notice, if I had left that cosine squared in there, it would just look crummy. Yeah, it would look crappier. Factoring by grouping is probably one of the easier things to do. We're just going to get some GCFs. And now I've got my two terms, they're both set equal to 0. And when I go to rewrite this, I'm just going to rewrite, instead of u, I'm going to put cosine of x back in. Because I'm done using u. I love u, but I don't need u. That was funny. Wasn't it? Not really. Thanks, Cole. Sure.
You shouldn't open up with I'm done using it.
What's that?
That just makes it sound like a jerk. Like I'm done using it. That sounds bad.
Yeah, you're right.
What happened to the 2 that you factored out before?
when you factor out this and you're setting it equal to 0, it has no bearing on the problem. It's just a scalar. It's just a scalar. It has nothing to do with it anymore. Okay. So now I've got two terms set equal to 0, don't I? Solve for x. What angle has a cosine value? -1/2. And what angle has a cosine value of +1? I'm skipping a little bit of the 1-2 steps there to solve to get x by itself. Are you guys okay with that?
Yeah.
I hope. Bounce them into your triangles again. There's a lot of stuff on some of these. 1/2 gives me what, the cosines, I believe. So it's a 30-60. So it's a 60-degree angle. But where will cosine be negative? What quadrants? 2 and 3. So that means this is at, if I come up pi over 3, I'm at 2 pi over 3. If I come down pi over 3, I'm at 4 pi over 3. What? 60 degrees is pi over 3. Reference angle go up,
Alright, that's right.
go down. Are those 2 points, are those 2 points equidistant if you're spinning all the way around? To get from 2 pi over 3 to 4 pi over 3 is different from getting 4 pi over 3 back to 2 pi over 3. So this is the case, you just write out plus 2 pi n for both of them. There's no easier way of doing it. And then back to what angle has a cosine value of 1. There. So this case has 3 solutions. Yes, sir.
So for the cosine, quadrants 2 and 3 because it's negative, right?
Yep.
The cosine.
Yep. That's all it is.
And then it's 15 plus 2 pi and you add 9 because that's.
They're not equidistant across one another. They're equidistant across one another to get from one point to the next. That's when you have a pi n. But since these guys are right here, it's not the same distance between these two and then coming back around. That's all. That's why general solutions take a little bit more time to get used to. Okay, that's why they take a little bit more time. Let's try some of these then. Let's see, it's 14.4. Let's just do this chunk.
Yeah,
860. Try those 10. See if we can get those through. So that's page 860. Yeah. So that's page. And it's section 14.4. That's good.